Session 2012. So study of discharging of a capacitor. A capacitor of capacitance C is initially charged under a voltage E. At t equals to 0, we connect across the terminals of this capacitor a resistance R equal 1 kilo ohm. So at the instant t, the A carries a charge Q positive and the circuit carries a current I. Write the relation between I and Q. So part 1, we have I is equals to minus dq over dt, since we are using a discharging process. Part 2, show that the differential equation across in terms of UC is of the form duc over dt plus uc over rc equal to 0. So according to the law of addition of voltages, we have uc is equal to u of the resistor, which means uc is equal to r times I, but I equal minus dq over dt minus C duc over dt. Then we substitute, so we'll get uc equal minus r duc over dt. This means, so we can put this part here and divide by, so this is rc, and divide by rc. So we'll get rc duc over dt plus uc equal to 0, dividing by rc. This means duc by dt plus uc over rc is equal to 0. And this will be the differential equation. The solution of the differential equation is uc equal d e exponential minus t over tau, and that d and tau are a constant. So the question is find d and tau in terms of e, r, and c. Since the solution, then it verifies the differential equation. So first, we'll do the derivative in order to substitute. So the derivative will be d minus 1 over tau, e minus t over tau. And we have the differential equation was of the form duc over dt plus uc over rc equal to 0. So we substitute, implies we'll get d e minus t over tau plus uc, which is de minus t over tau, and over rc is equal to 0. So بناخد the common factor هيطلع لنا d and between bracket minus 1 over tau plus 1 over rc is equal to 0. So this means that 1 over tau is equal to 1 over rc, then tau is equal to rc. This is the first one. Now, in order to find d, we'll take the initial condition. So, as initial condition, we have at t equals to 0, uc was equals to e, since it's a discharging process, which means that if I substitute in the equation here, so I'll get E equal d e to the power 0, which means that d is equals to e. And here we go, these are the constants. Part 4, show that after time t equal to tau, the voltage across the capacitor attained 37% of its maximum value. So we have uc equals to e minus t over tau. At t equals to tau, we'll substitute, we'll get uc equal e minus tau over tau. So equal to e to the power minus 1. So it's minus 1. So this will be here 0.37 e, which means uc equal 37% of e. Determination of the capacitance. Now, in order to determine the value of C, we use a convenient apparatus which give us traces during discharging the capacitor, the curve UC and len of UC. We proceed in the 3 following methods. So first method, give the value, referring to figure 2, give the value of E. So E is equal to UC maximum, which means it's equal to 8 volt. Using the result of part A4, determine the value of tau and deduce the value of C. So in the part A4, we said that at t equals to tau, we have UC equals to 0.37 E, which means 0.37 times 8, the maximum voltage. So we'll get here as answer equal to 2.96 volt. This is at t equals to tau. So نجم نحطها على رسمي 2.967. Yeah, it's approximately, this means approximately 3 volts. So by putting it on the figure on the graph, this is 3 volts, we'll get that tau is equal to 1 millisecond. So implies, using the figure, tau equal 1 millisecond. Now we continue and deduce the value of C. So نطلع value of C. We know that tau is equal to R times C, and we have the resistance equals to 10 to the power 3. So this means C equals to tau over R, which means 1 times 10 to the power minus 3, and over 10 to the power 3, which means C equals 10 to the power minus 6 farad. Now, second method, the figure 2 shows also the tangent KL to the curve at point M, 2 milliseconds and 1 volt. So we have a tangent. Referring to the figure, determine the slope of the tangent at point M. So in order to find the slope equals to A is equal to Y final minus Y initial. So نطلع الفigure Y final minus Y initial. So here on this figure, we can take Y final is 0, Y initial 3.125. So it's 0 minus 3.125 over X final was equals to 3, but 3 milliseconds. So yani it's equals to 3 times 10 to the power minus 3 and minus 0. So هيطلع عنا الأنسر minus 1041.6. This is the slope. Determine the value of C, part B. So we know that the intersection, so we know that in order to find the value of C, we can use the differential equation. Why? We know that the slope here, it's equals to duc over dt. The slope of tangent, it's equals, the slope of tangent is equals to what? Is equals to the derivative. So at t equals to 0, which means that now we'll use the differential equation. We already have duc over dt plus uc over rc is equals to 0. Now at t equals to 0, we will find duc over dt. So at t equals to 0, duc over dt is equals to minus uc over rc. But at t equals to 0, you see here zeta e, so equal minus e over rc. And then since we have the slope, so here, this is the slope, implies a equal minus e over rc. And the question is find c, so here it's the slope, which means that c equals minus e over r times a, واللي هي the slope. We have e, we have r, we have the slope اللي طلعناها بهيدا البارت قبل, so we'll get c equal 10 to the power 6 farad. So هيطلع عنا times 0.96 تقريبا, يعني it's equal approximately to 1. Now, third method, determine the expression of len uc in terms of e, r, c, and t. لنطلع الاكسبريشن للن uc هطلعت معنا uc equals to e minus t over tau, which means len uc equal len of e, but we have len a times b, so it's equals to len a plus len b, and this means that len uc is equal to len e minus t over tau. So this is here the equation. Show that the shape of the curve in figure 3 is in agreement with the obtained expression. So if we look at the curve, we have at the curve in this figure, we have a line not passing through the origin and decreasing. So if I put here the equation, this is y equals. So here we have len e, it's b, okay, plus I have here it's the slope at, implies it's of the form y equal at plus b is a line not passing through the origin, and what also, and a equal minus 1 over tau smaller than 0 implies it's decreasing. So it's verified. Now part C, referring to curve 3, determine again the values of E and C. Now, in order to determine the value of E, we can take at t equals to 0. So at t equals to 0, we have len of UC using the figure is equal to 2.08. But len of UC, so by substitution here at t equals to 0, but len of UC equal len E minus t over tau. This is at t equals to 0 راحت, which means len of E equal 2.08. This means I can find E equals to 8 volts by putting the exponential both parts. Now, we continue, we still have to find C. So كمان رح نستعمل less UC but we're at t equal to millisecond. So at t equal to millisecond, another point, we have len of UC is equals to 0. So كمان by substitution, this means substitution. So we have 0 equal len of E minus 2 millisecond over tau, which is RC. Now this is 2 times 10 power minus 3 seconds. The R احنا معنا إياها. Okay, so we have R, and then we still have to find the 10 to the power 3. So this means we can find C is equals to 0.96 times 10 power 6 farad. So by doing just the substitution,